Welcome you all to the session on analysis and design of algorithm. Today's session, let me discuss more on how to analyze the recursive algorithm. So with a different problem. Okay. So now today's session, let us take the one more problem, that is tower of an eye problem. So tower of an eye problem is is like we will be having n disk and we need to place all the n disk to the destination needle in such a way that whenever we are placing one disk, every time we need to place only one disk from one needle to another needle, and whenever we are placing the disk, so on top of the smaller one we should not place the larger one. So these are the some of the criteria for tower of an eye problem. So we need to transfer all the n disk from source needle to the destination needle in such a way that only one disk can be moved at a time. And one more thing is, here we should not place whenever we are placing the disk from one needle to another needle, we should not place the larger disk on top of the smaller disk. Okay, so that is the tower of an eye problem. I know that. So you people already have learned in data structures. Okay, so let us solve the same problem again here. So what is the problem? Tower of an eye problem. So tower of an eye, so in the tower of an eye we will be having n disk. Okay, we need to transfer all the n disk from source needle to destination needle. Okay, so whenever we are transforming this n disks from source to destination, so we need to move only one disk at a time, and also whenever we are placing, so on top of the smaller one we should not place the larger one. We cannot place the larger disk here. Okay, so now, so in order to solve this, we are writing the recursive algorithm in order to solve this problem. So what we are doing here is, so we are calling the function tower of an eye with n disk. But here using only source needle and destination needle, we cannot place. Of course, if you have only one disk, then you can transfer from source to destination needle. But if you have more than one disk, then you need a temporary variable. Okay, so we need to transfer the disk from source to temporary, and then temporary to source. So now, so for the first call, what happens is, so from source to temporary. So now our destination is what? Our temporary disk, needle, and then from temporary to destination. So in between what we are performing? We are performing the move operation. From where to where we moved? From source to temporary we moved, and then after that, so temporary to destination we are moving. So that is move operation is performing. So from source to temporary, then move operation, that is the move operation we need to perform, and then we need to transfer all the remaining disk from temporary to destination. This is the procedure for solving this problem. Okay, so and what is the base condition for this recursive algorithm is, if you have more than two disks, or it is not possible to transfer directly. Why? Because on top of the larger one we will be having the smaller one. So whenever we are placing from left to right, so that is source to destination, so we are moving the smaller one. So if you have only one disk, so the larger one, this is 1, and if you are considering 2, so if you are transferring to destination, now what happens? You can transfer, the first one is 2, we can transfer. Next, the remaining, in the remaining we will be having 1, and here we will be having 2. So we have moved from where to where? Destination, source to destination. But now source, in the source we have 1, but this disk is the larger one. Can I place here? No, I can't place it here. So if I want to place, now what happens? This is 2, and on top of this 2, we are going to place 1. But this is wrong according to the tower of Hanai constraints. So for that what we need to do? So we need to take one more needle, that we call this one as a temporary needle. So temporary needle and destination needle. So therefore how many needles we have? We have a source, temporary and destination. 3 different needles we required. So that means that one more extra needle we are using, that is nothing but the temporary needle we are using. Okay. So now what happens? So first directly from source to destination if you are moving, the same problem will occur. So now what have to do? We have to transfer the the elements, that is disk from source to temporary, and then temporary to disk we can move. Now what happens? So you have only one, so we are moving disk number 2. In the destination we have empty. So source, temporary, destination. Now we need to move. Either we need to move 2 or either we need to move 1. Here we have remained with 1. Okay. So if you have only one disk, where we can place? Directly to the destination machine, right? So we are transferring the disk from source to destination if you have only one disk. So we are moving to here destination. So into the needle destination we have moved the disk number 1. So in the temp we have 2. In the source we don't have anything. Now from temporary to destination we can transfer the next disk. So source is empty, so that we are not transferring anything. Now temporary to destination we need to move. So that is 1. On top of this 1 we are moving the next disk. This is how we can transfer the entire disk from source to destination needle. So now how to write the recursive algorithm for this procedure? See, so one thing is, if n is equal to 1, that means that if you have only one disk, then directly you can transfer from source to destination. Move disk 1 from source to destination when if n is equal to 1. Okay. If n is greater than 1, by that time what we need to do? We need to transfer the source to temporary, and then we need source to temporary means we are moving, right? So move operation should be performed over there. Okay. Once you call the function. After that temporary to destination we need to move. Okay. The remaining disk has to be moved from source to temporary, move statement, and then temporary to destination. This is how we need to write. Okay. Let us write the algorithm first. So algorithm. So algorithm, so for the sake of tracing and all, I will keep it short, TOH of, so here we required n. Why? Because n holds the n disks, okay, the number of disks we can say, and we need to keep needles, that is source, temporary and destination. Source, temporary and destination. Okay. Next, after this, so the purpose to solve the Tower of Hanai problem. Okay. Second thing, input. What is the input? So that is your n needles, so sorry, disks. Okay. Positive integer, holds the number of disks. Okay. Next, output, move all n disks from source to destination. Okay, right? This is what we need the output. So next, general case, if n is equal to 1, move operation we need to perform, move disk 1 from source to destination. See, in this call, if n is equal to 1, source is source as it is, destination is destination as it is. So according to the call, so what is the source, what is the destination, according to that you need to write the statements. Okay. Next, after that, if n is equal to 1, move statement. Else what we need to do? We need to transfer from source to temporary and then temporary to destination. In between we should have a move operation. Why? Because source to temporary we are moving and then temporary to destination we are moving. So we should have a one move statement in between. So we are calling the same function tower of Hanai of n minus 1 disk along with source will be as it is. Okay. So we are transferring to what? Where? To the temporary variable. So temporary will become your destination now. Okay. And your destination will become temporary. Okay. So now these two values is get interchange. That is, your destination will become temporary variable and temporary needle will become destination needle. Okay. Why? Because we need to move from where to where? Source to temporary. That's why. Okay. And here we have a one move operation. Move disk. Here not 1. Okay. Here disk number n. From where to where? From source to destination. Here also you can say n. Why? Because n is equal to 1, then you are going to execute this. Either you can write 1 or n, whatever it is, same. Okay. And next, from source to temporary we have moved. Now we need to move from temporary to destination. Now temporary to destination means your source will become temporary and temporary will become destination. Okay. Temporary will become the source. Okay. TOH is equal to, so the remaining disk should be moved from where to where? From temporary to, so that is temporary to destination. Okay. And your source will become the temporary variable. Remember, for the first call these two variables get interchanged and for the second call these two variables get interchanged. Why? Because first source to temporary we are moving and then temporary to destination we are moving. Okay. Let us take the example and calculate the steps. Okay. So let me take the simple example, that is how many moves that are required to move 3 disks from one needle to another needle, that is source to destination. Okay. So now TOH of, usually for tracing it is better to write the recursive tree for this function. Why? Because here we have a 2 calls, right? So definitely it is going to do the tree structure. Okay. So for that I am going to write the binary tree structure for this. Okay. So TOH of 3 comma source, temp, destination, right? So now we need to check what? So the same function is going to invoke with n is equal to 3. So when n is equal to 3, we need to check with is n is equal to 3, that is 3 is equal to 1, false. If it is false, 3 is equal to 1, false. So the left call we are going to make TOH of, so n minus 1 is 2. So S will be as it is, these two get interchanged, that is T comma D. Okay. Next, again the same function is going to invoke with n minus 1, that is 2. Now n will become 2. N is equal to 2, that is that is 2 is equal to 1, false. Again we are going to call the left function, that is the same function. This function is going to invoke the same function until unless this function becomes true. Okay. So 1 S T D. Okay. So now these two get interchanged. So we need to transfer all the remaining elements to the temporary variable, that's why. Okay. Now n is equal to 1. So n is nothing but your 1. 1 is equal to 1 is true. If it is true, what is the action? So action is move disk n from source to destination. What is n? N is 1. So move. So first statement to be executed is first move disk. What is the disk number? Disk number is 1 from source to destination. Source is source only, destination is destination only. Therefore, source to destination. Okay, this is the move number 1. Okay, next what? So this is where move operation is performed. Now we need to come back. So once it is come back, so the next operation, this is completed now. The next operation is what? We need to move disk n from source to destination. That means that here move operation has to be performed. That's it. That is second move. Move disk number. What is the disk number here? What is the disk number? 2. 2 from, what is the source here? Source as it is. To destination. What is the destination here? Temp. That is T. Okay. Temporary is T. Okay. Next. After this move, we have a write call. So we need to call the write function. That is TOH of n minus 1 means 1, comma. Now these two get interchanged, right? So that is your destination and S and T. So these two get interchanged. Now we need to move the disk. This is the third move, right? Why? Because here n will become what? 1. That's why. So this condition is true. If so, then we need to perform what? Move operation. That is the third move is move disk 1 from destination to temp. So here source is what? D and the destination is T. Therefore D to T. That means that destination to temporary. Okay. Next, fourth step we need to find out. So now the control comes back here. So all the steps has been finished. Now it will comes back here. Okay. This and this. Now, okay. This is how the recursion function works. Now, so all the left function has been performed now. Now we have left out with the rightmost one. Okay. In between we have one more. That is move operation we need to perform. That is which move? That is the fourth move we need to perform. What is that? Move disk. Which disk? Third disk. Disk 3 from where to where? Source to destination. Source to destination directly. Okay. Next, after that, write call. What is the write call? TOH of 2, comma. Now, in the write call, these two has to be changed. Why? Because temporary to destination we need to move. That's why source will become the temporary and destination will be as it is. Right? Now, again the same function is going to invoke with n is equal to 2. Now, what happens? So, 2 is equal to 1 false. So, left call TOH of 1, comma. Now, in the left call, these two. Why? Because temporary will become destination, destination will become the temporary. Therefore, 2, comma T, D, yes. Okay. So, if you understood the algorithm very well, it is easy to write the binary recursion tree. Otherwise, you can't write the binary recursion tree. Remember. Okay. Now, in the right hand call, before that, we have n is equal to 1. The same function is going to invoke with n is equal to 1. Now, n is equal to 1. This is true. 1 is equal to 1 is true. Therefore, move 4 is over. Now, this is move 5. Move 5 we need to write. So, what is the move 5? Move disk. What is the disk number? Disk number is 1 from source to destination. What is source here? T. T to destination is what? Yes. T to yes. Okay. Next, after this, so we need to check what is the sixth move. So, if your control comes back, after that write call, we have a move statement. Here we have a sixth move statement. What is the disk number? 2 and destination, so source is T and destination D itself. So, therefore, sixth move is move disk number 2 from where to where? Temp to destination. T to D. Next, write call is remaining. Write call is what? TOH of 1, comma. Now, these two get interchanged. Yes, T, D. That is, this is the seventh move. This number is what? 1. So, seventh move is move disk 1 from source to destination. Okay. Now, the control comes back, all the operation has been performed. Next again control comes back, all the operation has been performed. So therefore, how many moves has been taken place for 3 disks? 1, 2, 3, 4, 5, 6 and 7 moves. So let us analyze and find out, so how this 7, so for the given 3 needle, disk, so how it is going to take 7 moves, okay? Is it correct or not? We need to check, okay? You can check the cross verify these moves also, okay? From first, so we will be having all the 3 disks, okay? From move 1, sorry, this is 1, 2, 3, move the first disk to the source to destination node, okay? First move. Second move is move the disk 2 from temporary, correct? Next, disk 1 from D to T. So, D to T we need to transfer. That is, here we have 3, 2, on top of 2 we have 1, that is also correct. Next move, that is move disk 3 from source to destination. So, source to destination we need to move. That is 2, this is 1 and this is 3. Next, move 1 to temporary to source. That is here 1, here 2 and here 3. Now, move disk 2 to temporary to destination. That is 1. On top of 3 we can place 2. That is correct only. 2. And now the remaining is disk 1 from where to where? Source to destination. So we can move this from source to destination. So the moves whatever we have used, that is correct. Okay, correct moves we have. So be careful about the numbering. Why? Because so here according to the recursive functions or calls we have made, according to that it should work. Binary tree should work. So that is left call, middle, node and then right call. So perform all the left calls and then the node operation and then the right operations we need to perform. Okay. So now let us analyze the algorithm and find out whether which yields the same number or not. For analysis, first step, the input, that is n disk, right? Second step, BO, that is move operation. Third step, the number of times the basic operation executed is based on n disk only. Okay. So therefore there is no best case, worst case and average case, directly worst case itself. So fourth step, we need to set up a recurrence relation. So what is that recurrence relation? T of n is equal to, here 1 move if n is equal to 1. If n is equal to 1, how many moves? 1 move has to be taken place. And if n is greater than 1 by that time, so here what is the basic operation? Move, which takes 1 unit of time. Okay, and rest are n minus 1 recursive calls, tower of ni of n minus 1. Therefore 2 t of n minus 1 plus 1 is for what? Move operation. So now we need to solve this recurrence relation using backward substitution method. So how to solve this? T of n is equal to 2 into t of n minus 1 plus 1. Call this equation as 1. And remember, you know the value of t of n if n is equal to 1. T of 1 is equal to 1. Okay. So now let us replace n by n minus 1 to get t of n minus 1. So t of n is equal to 2 into t of n minus 1 plus 1. So now replace n by n minus 1. So now what happens? In the place of n we have n minus 1, 2 into t of n minus 1 minus 1 plus 1. So that is 2 into t of n minus 2 plus 1. So this is for what? T of n minus 1. So substitute value here. Here we have 2, here 2, keep it aside, and then now we need to substitute the value of t of n minus 1, that is 2 into t of n minus 1 plus 1, and another plus 1 here. Okay. So now what happens, 2 into 2 is, instead of multiplying the things, so let me keep it in a power for the sake of ease of calculation or solving the equation, into t of n minus 1 plus plus 2 into 1 is 2 plus 1. Okay. So don't add these numbers. Why? Because it will going to yield you the series of these numbers. Okay. So because of that reason, don't add these two terms. Okay. So the next term will be, so using the same equation, we need to calculate t of n minus 2, that is t of n is equal to, by replace n by n minus 2. Why? Because here we need what? N minus 2 value. Into t of n minus 2 minus 1 is 3 plus 1. Okay. So substitute this value here in this place. So now it will become 2 square into, so that 2 into t of n minus 3 plus 1 plus 2 plus 1. So now it will become 2 square into 2, that is 2 cube, into t of n minus 3 plus 2 square into 1 is 2 square, plus 2 is can be written as 2 to the power of 1 plus 2 to the power of 0. So like this we can write. So if you keep on calculating the values for this using the backward substitution method, the last term whatever you are going to get is so now if you keep on calculating the values, what you will get, 2 to the power of n, t of n minus n, but here we don't know the value for n minus n. So you know the value for n minus, so t of 1 value you know, right? If n is equal to 1, then the value is 1. So because of that reason, go up to n minus 1th term. Okay, n minus 1th term we need to go, then it will be, so 2 to the power of n minus, see, observe here, if it is 2 cube, this is 2 square. Therefore, this is the n minus 1th term. Definitely this term will be n minus 2 term. Next, n minus 3 plus etc. 2 cube plus 2 square plus 2 plus 1 or 2 to the power of 0. So, here t of n minus n get cancelled. So, n minus of minus is plus. So, t of 1 is 1. Okay. So, t of 1 is 1 if n is equal to 1. We know that. So, 2 to the power of n minus 1 plus 2 to the power of n minus 2 plus 2 to the power of n minus 3 etc. 2 to the power of 0. So, this can be written as the summation equation in the summation equation form. So, from I is equal to 0 to n minus 1, 2 to the power of I. Okay. So, this can be solved using the formula. So, summation I is equal to 0 to n 2 to the power of I. By using that equation, you can have the value 2 to the power of n minus 1. This is how we can calculate the value of 2 to the power of n minus 1. Okay. So, let us take the value here. Previously, we have traced for when disks, number of disks are 3. So, let us calculate here. If n is equal to 3, what is the moves we have done? That is 7 moves we have done, right? So, let us calculate here. Apply the same value. T of 3 is equal to 2 to the power of 3 minus 1. That is 2 to the power of 3 is nothing but what? 8. 8 minus 1 is 7. The same thing. So, whatever the number of moves we did, that is correct. So, that is, so 2 to the power of n minus 1 is the number of times the basic operation executed. That is nothing but the time efficiency of the given algorithm. That is the problem of Tower of Hanoi problem. Okay. So, this is how we can calculate the time efficiency function. Okay. So, in other sessions we will continue with some more examples. Okay. Thank you.